Oh, we're here. I'm sorry, I was thinking about a different problem. So let's just take a look at, let me get this out of the way. Let's just take a look at problem 44. Okay. Oh, I kind of like problem 43. I was just reading, sorry. So, but a dynamite blast at a quarry launches a chunk of rock straight up in the air. 2 seconds later, it's going at 15 meters per second. Okay. Assuming air resistance has no effect on the rock, calculate the speed at the launch and calculate the speed 5 seconds after the launch. It's free. It doesn't make any difference. You know, they make a big deal that it's free fall. It's a free fall problem. In other words, but all they're doing is saying that, hey, the acceleration is negative 9.8 meters per second squared. That's all right. That's okay. So do I know an initial velocity here? No. Do I know a time? Yes. Do I know a final velocity? Yeah. Do I have an equation that talks about the final velocity equals the initial velocity minus the acceleration times the time? Or we have it this way, equals V naught plus AT. Okay, so I'll just say, well, so V final is 15 meters per second is equal to the initial, which I don't know, plus negative 9.8 t. So, well, that plus negative 9 is plus negative 9.8 is clumsy. That's why we just say it's V naught minus 9.8 times 2. Oh, so I got 15 meters per second is equal to V naught minus 19.6 meters per second. Because look, this is meters per second squared times the time. So one of those seconds drops out, gets canceled. So it's 15 plus 19.6 equals V naught. That's all. And then it says, what about 5 seconds after the launch? How fast is it going? Okay, let's just use this again. So this time, let's let t equal 5 seconds for part 2. Plug in the same thing. So 5 seconds after the launch, I don't know what V final is. Well, that would equal the initial launch time, the initial launch speed, which is 15 plus, well, what's 35 minus 0.4? 34. Oh, man. See, I'm brain dead. It's Friday. I can't add 15 plus 19.6. 34.6. All right, so I've got 34.6 meters per second minus 9.8 times 5. So V final is equal to 34.6. Now watch, 34.6 minus 9.8 times 5 is equal to negative 14.4 meters per second. So what does that tell me? It's going down. It's gone up, and now it's coming back down. All right, let's do one more, and then that's more than enough for today. All right, so here we go. So let's look at 46. A ball is thrown vertically upward, which is the positive direction. A little later, it returns to its point of release. The ball was in the air for a total of 8 seconds. What is the initial velocity? Neglect air resistance. All right. First of all, if we're going to neglect air resistance, then I know this is true. I just want to examine this problem for a little bit. T equals 8 seconds. That's how long it's in the air. I don't know V initial. I don't know. However, if there's no air resistance, it came up with this speed V naught. And guess what? When it comes back to its same position, V final, the magnitudes are the same. After it's gone through, it's like that. The magnitudes are the same. They're just in the opposite direction. So t is equal to 8 seconds. So guess what? What's the acceleration? That. So what do we have? Once again, bread and butter. V final is equal to V initial minus 9.8 times t. Well, V final is equal to minus V initial, which is what I was trying to show you, is equal to V naught minus 9.8 times 8 seconds. So I wind up with negative 2V naught is equal to negative 9.8 times 8. So I divide both sides by negative 2. And I wind up with V naught is equal to 4.9 times 8, which is real close to 40. 39.2 meters per second. That's free fall. Just the acceleration is equal to 0. That's all.